So about a month ago, Tim Sweeney, CEO of Epic Games, finally responds to all the complaints that we've been having for a long time about Unreal Engine 5 being terribly unoptimized. Basically, he said,
"User error."
So I decided to jump into Unreal Engine 5 myself to investigate and see how easy it is to optimize from the beginning, and then package these games for PC only so that I can see how they perform on Winlator on my Android devices. Why am I doing this? Because just about every new game that is coming out these days is and will be using Unreal Engine 5. And most, if not all of them, are built for PC with the maximum settings. I used a few of the UE5 game presets that come with the engine, and even created my own very basic scene, without making any optimizations at all in the project preferences. What I did do was make sure they can work with DX11, because we all know that. Then packaged these up for PC x64 only. Then I loaded them up on Winlator on my Snapdragon 8 Gen 3 tablet to see how they perform. The results are as expected. All of these small scenes, even the most basic one that I made, run at around 20 FPS. Let's test them on my Snapdragon 8 Elite. Even the most basic scene would load in at 0.2 FPS, but still not be able to render anything, just a black screen. Strangely enough, the blank landscape scene did render, but only around 0 to 1 FPS. This looks very familiar, but still, why is it running so much worse on the Elite? So I know what you're probably thinking right now. Before I move on, I need to clear up a common misconception. Now with that out of the way, I tested the Qualcomm drivers for the Snapdragon 8 Gen 3 and confirmed that it is the Qualcomm drivers and not just the Snapdragon 8 Elite that's the problem. Phew, that's a relief for all you Elite copers out there. So I put this away and went on to other stuff. A few weeks later I decided to come back to this and loaded up one of the test scenes on the Elite, because I got the idea to copy across performance optimizations that I discovered for Chronos, which was also a UE5 game that already ran surprisingly well on the Snapdragon 8 Elite. In fact, I think this is one of the first UE5 games that ran significantly better on the 8 Elite than the Gen 3. I wanted to find out what it is that makes it run so well on our Android devices, because on PC it was still criticised to be as unoptimized as any other games upon its release. What is it about games like Chronos and Soul Slinger that run so well on emulator and still looks so much better than this? I loaded up what I thought was the basic test scene. Hold on. What is this? I managed to track down the original source files. I figured maybe I had built it using a different version of UE5. Nope, it was built using the same version of UE5 as the other test scenes. Then I remembered something. For those recent test scenes, I deliberately left it at maximum, which was the default. I wanted to see how badly optimized a game could be if an amateur developer went straight into the engine and did not bother with optimization. What if I had chosen scalable for that test scene and forgot about it? I went ahead and repackaged one of the test scenes as scalable. It worked! Now to go and tell every developer to rebuild their games and future games using the scalable setting. Okay, realistically that's never going to happen. Developers that want their games to be cross-platform most probably would be using this setting to optimize further to reach as many platforms as they can. Other developers may just be focused on targeting high-end hardware. So instead I decided to try and figure this out by myself. How I could possibly get something out of these test scenes that I could utilise to mod games like Expedition 33 to perform better on my Snapdragon 8 Elite. I did a deep dive into Unreal Engine 5 game modding, discovered Unreal Pack, which comes with all versions of UE5, used it to unpack the pack files of the maximum and scalable versions of the scenes so that I can do a comparison of the assets inside. Until I discovered this. This looks like a whole bunch of console variables for graphics settings in an Unreal Engine 5 game. What if I compare the maximum and scalable versions of this using diff checker? They are definitely different. What if I copied all the graphics parameters of default Engine.ini from the scalable version into the Engine.ini of the maximum version of a different test scene? Remember, this was how it ran on the Snapdragon 8 Elite. Wow, it worked! Look at the frame rate! So there must be a variable or group of variables in here that makes the difference. I worked out the fastest process of elimination by removing half of the variables and seeing which half it worked and which it didn't. Eventually I landed on this variable. Maybe there were other performance mods in those other variables, but this was the one that made the biggest difference. I tried it on the other test scenes and confirmed exactly the same thing. Now let's try it on Expedition 33. The menu now runs smoothly. Let's see if we can get into the game. The game definitely runs now, but not the 60 FPS that I was dreaming of. So I guess Expedition 33 is just really badly optimized after all then. So now that you know this, whenever you see any other UE5 game that struggles even in the menu, you'll know that this might be a possible solution. Note that this is not a tutorial video. I will do a tutorial in the future for beginners. So what's actually going on here? Well, it was pretty simple. At maximum settings, r.anti-aliasing is set to its maximum value of 4, which is TSR, proudly Unreal Engine's very own upscaling tech. This is Silent Hill F running on my RTX 3080 when I first booted it up. Then I very quickly realised it was running on TSR. r.anti-aliasing equals 0 turns off anti-aliasing, which is why on Black Myth Wukong, switching to the very own proprietary NXSR released the frame rate constraint immediately. On Expedition 33, TSR is the only option in the in-game settings, but forcing this variable turns it off. Well, I hope that helped folks, and if you already knew this, then I hope you at least got some entertainment out of this video. Otherwise, sorry for wasting your time. So if you've been trying to get Silent Hill F running on your Snapdragon 8 Elite by setting r.anti-aliasing method equals 0 in the Engine.ini, you might notice a slight hitch. And no, the file isn't being deleted, unless you don't know how to set it as read-only. It seems like this variable only works for the splash screen videos. Turns out that the actual game requires that you set this additional variable in game user settings from TSR to AMD FSR. And there you have it, the game will now load.
私は一人でも全然寂しくないの。仲間。
あってたまるか、そんなこと。